Hello viewers, welcome to my channel. In this video, we will discuss the minimum and maximum steel reinforcement percentages in civil engineering structural elements. These elements include beams, columns, slab and foundation. First of all, we will discuss that what is the minimum and maximum reinforcement in beams. Whenever we see a beam structure, basically beam is a horizontal member. Let us say this is the beam cross section and its dimension are 300 millimeters by 400 millimeters. And we want to determine that how much reinforcement will be required at a minimum level. I mean, what is the percentage of minimum reinforcement to be used in this beam cross section? This is the cross-sectional area of the beam. So what will be the minimum percentage? So basically, according to Indian standard 456, IS 456, the minimum requirement or minimum percentage of steel in the beam cross-section is 0.2%. So if in the value or in fractional value, we can say that it is 0.2 by 100 times the cross-sectional area of the beam. So what is the cross-sectional area of this beam cross-section? This cross-section may have different values. This may be in inches, this may be in millimeters. So we need to calculate the area of cross-section of the beam. So what will be the area of cross-section of this beam? Simply we can multiply with the depth and width. We will multiply depth and width of the beam cross-section. So we can say that 0.2 by 100 times the cross-sectional area is 300 millimeters times 400 millimeters. So when we multiply and divide these values by 100, it will give us the 240 millimeter square. It means that the minimum area of steel reinforcement in the beam with a cross section of 400 by 300 millimeters is 240 millimeter square. So we will say this as AS minimum. So this is the area of steel required at a minimum level. So what will be the maximum reinforcement? This is not the minimum, this is maximum reinforcement. In all slides, this side on the right side, we will have the maximum reinforcement. So what is the maximum reinforcement for a beam cross section according to IS 456? So it is mostly the 4% of the cross-sectional area of the beam. So in fractions, it will be 4 divided by 100 times the area of cross-section of the beam. So simply we can say that 4 divided by 100 multiply with the 300 millimeters by 400 millimeters. If we cancel these two zeros with the two zeros in the numerator, then we will have 4800 millimeter square of the steel area, which is a maximum value. So if we change the cross-sectional dimensions of this beam cross-section, say these are 400 millimeters by 600 millimeters, then the value of AS minimum and AS maximum will be different as compared to these values. But percentage will remain constant. The minimum percentage is 0.2%, while the maximum percentage is 4% of the cross-sectional area of the beam. For the same case, we can proceed with the column. The maximum and minimum reinforcements for a column cross-sectional, see, say we have this cross-section of a column, and this column is of square shape, may 600 millimeter by 600 millimeter. This is just an assumption, and we want to use the reinforcement in the column. So what should be the percentage of this reinforcement in the column? So still we need the cross-sectional area of the column. What is the cross-sectional area of the column here? This will be 600 millimeter by 600 millimeter. So minimum reinforcement in the column as per IS 456 is 0.8% of the cross-sectional area of the concrete column. So it will be 0.8 by 100 times 600 by 600. So when we multiply this 600 by 600 and divide by 100 and multiply with the zero point 0.8, it will give us an area of 0.2880 millimeter square. And if we want to know the maximum percentage, so maximum percentage of steel is the 6% of the cross-sectional area of the column. So simply you can say it will be 600 or 6 by 100 multiplied by the 360,000. So simply it will be 21,600 millimeter square of the steel area at a maximum value. It means that in this cross section you cannot use the steel more than 21,600 millimeter squares, but you can add on the same way you cannot use the steel reinforcement lesser than 2,880 millimeter squares. So for the case of slab, the minimum reinforcement is 0.12%, while the maximum reinforcement is the 4% of the cross-sectional area of the slab. So simply if we have this slab of, let us say it is for 15 millimeter depth and its span is, let us say, 600 millimeters or somewhat like this, you can say this as 4,000 millimeter. So what will be the minimum reinforcement requirement of this slab? So it will be 0.12 divided by 100 times the area of cross section of slab. So 0.12 by 100 times 4,000, the length of the slab, millimeters, times 15 millimeter. So it will be 72 millimeter squares. This is the minimum required area of steel for the slab. And if we want to determine the maximum area of the steel in slab, it will be 4% of the cross-sectional area of slab. So simply, when we multiply 4,000 by 15 and divide by 100 and then multiply with the 4, the answer will be 2400 millimeter square. Mean you can use, simply we can write it as 72 millimeter square is less than AS is less than 2400 millimeter square with the equal signs. It means that you can adopt the area of steel for this slab cross section within these values or these values. If you want to use the minimum reinforcement, it will be 72 millimeter squares, and if you want to use the maximum reinforcement, it will be 2400 millimeter squares. But you cannot use the greater value than this and lesser value than this. And the last structural element is the foundation. For foundation, the minimum requirement according to IS 456 is 0.12%, same like the slab. The foundation, let us say you have a foundation and the cross-sectional area of the foundation is this one, 4,000 millimeter square by 6,000 millimeter square, then the minimum reinforcement is 0.12%, means this into this. So you can calculate the minimum requirement of steel for this footing. Thank you very much. Subscribe my channel to see more videos.